vector और scalar. Hello students, welcome to our physics discussion, that is physics in a smart way. So in the last some videos, we are discussing vectors, and because vector is an essential tool to deal with physics, we are continuing with them. Major portion is completed. So far as analytical methods are concerned, addition of vectors was our issue. We know the first analytical method is parallelogram rule or cosine law that has got its own merit and demerit. Second analytical method is component style or rectangular component method. We are going to the third style, that is third analytical method, that is unit vector method. Unit vector, or some people also say that is IJK method. Cap, K cap, I cap, J cap, K cap method. Okay. You might be slightly surprised if you have not seen them before, but doesn't matter. They are not monsters. They are simple and dealing with them is very easy. Let us consider an hypothetical case. We got two vectors. One is A, other is B. Vector A, as it is shown, that makes an angle of 37 degrees. And one thing here, if you got a right angle triangle, you might have known since your school level, the right angle triangle, one of the angle is 37 degrees and the remaining angle will be nearly 53 degrees. If it is so, then the sides of the triangle will be in the ratio, the perpendicular will be 3, base will be 4 and hypotenuse will be 5. So thereby, we can very easily determine its sine theta. Sine 37 degrees will be equal to 3 by 5. A bit useful. My point is bit friendly number compared to sine 30 or cos 30, where root 3 and root 2 they do appear. Cos 37 degree will be equal to, so to say, 4 by 5. You just keep that in mind. If the angle is 37 degree of a right angle triangle, other angle will be automatically 53 degree because some of them must be nearly 90 degree. So thereby the side ratio will be 3, 4 and 5. Okay, sometimes it is helpful. This angle is 45 degree, that the angle that vector B makes. You know sine 45 and cos 45, they are having the value of 1 by root 2. To make our calculation convenient, the vector value also is a multiple of root 2. So vector A is of magnitude 10 unit, remains in the positive xy space, directed like this. Vector B is directed like this, having a magnitude of 6 root 2. Vector A makes 37 degree, vector B makes 45 degree. Okay, our basic job, as usual, we have not come out of it. Our basic job is to find out the addition of vectors, that is A plus B. By the time that we have interacted, since the starting of vector and scalar, you have realized that to describe a vector, at least it takes a sentence. You have to describe its magnitude, you have to describe its direction. Symbolically, we write like this, but if you put in the vector value, if you put in the vector value, vector A 10 and vector B 6 root 2, that equation will be horribly wrong because vectors are to be added vectorially. They are not to be added like a scalar, and that job is slightly difficult when you compare to the addition of scalars, same type of scalars. I got a length of 3 meter, other length is 2 meter. I am adding them. So straight away we say 3 plus 2, that is equal to 5 meter. But vector cannot be added like this. So at this stage, it may seem inconvenient to you that, okay, it's difficult to deal with vectors and all that. And in your mind, you must be thinking of a way out so that can't vector be presented, can vectors be added just like the scalars? The answer to your question is yes or no at the same time. If somebody says no, the meaning is to be, or you have to understand that unlike scalars, vectors cannot be added in a way that somebody takes their magnitude and just add them in a scalar way. If somebody says yes, the vector can be presented in an algebraic way in such a fashion that you don't have to describe the vectors in a big way and go for their finding their x and y components and all those things. Those things, somehow our job will be easy. You may be slightly confused, but let me make you clear. Okay, the idea that you get in describing this method, or in this method, that is unit vector method, IJK method, is in fact, this is not an independent or a unique style. It derives its fundamentals from the components and all those things, the thing that you have learned. Let us say we consider another diagram where we show positive x-axis, positive y-axis, positive z-axis. A vector of magnitude 1, mind it, magnitude 1, along positive x-axis is denoted as I cap. Usually this symbol cap, it denotes a unit vector, And once you learn it, then you know its meaning. A vector, you might ask, why, sir, it is I cap? Oh, that's a convention since time immemorial people have started using that, we are still using that. A vector of magnitude 1, mark my words, and directed along positive x-axis is normally denoted by I cap. Similarly, a vector of magnitude 1 and that is directed along y-axis is denoted by j cap. And the same thing happens with z-axis. A vector of magnitude 1 and that is along positive z-axis. Positive z-axis R is marked as k cap. So from my statement, it is obvious that I cap magnitude, j cap magnitude, and k cap magnitude will be always equal, that is equal to 1. You might wonder why it is 1, why not 2 or 3? 1 is a typical number. The number 1 has got some special advantage. And here the biggest advantage you are going to utilize is that you multiply 1 with anybody. You multiply 1 with anybody, the value remains unchanged. The value remains same. The value remains same. So thereby, their magnitude is 1. If I would have taken the value 2, then you multiply 2 with anybody. As you know, clearly, the value will be increasing or becoming double. That you do not want, because that can create further complication. Okay. So as I told you, a vector of magnitude 1 and directed along positive x-axis, we mark it as I cap. Similarly, a vector of magnitude 1 directed along positive y-axis, we put it by a symbol as j cap. A vector of magnitude 1 and directed along positive z-axis, we put it by the symbol that is k cap. Okay. So here your question can be, Okay, I got a vector that is along positive x-axis, but that vector is not having magnitude 1. That vector is having magnitude 3. But that vector, you may claim your vector is having a magnitude 3 and directed along positive x-axis. So I can very easily present it as 3 cap. Your vector was having a magnitude 3, but the number 3 gives the magnitude only. So when you multiply with I cap, we know unit vector is having magnitude 1. So the vector value, your vector value won't be changing, but that will be converting the whole thing into a vector of magnitude 3 and direction along positive x-axis. Okay. Somebody may wonder if my vector is not along positive x-axis but along negative x-axis, then very easily we can make it as minus 3 I cap, because you know here negative sign denotes the direction, stands for the direction. If plus I cap is along positive x-axis, then minus I cap is along negative x-axis. Okay. And one question here can be that what type of vector this I cap, j cap, k cap will be, or when you multiply them by some number, what type of vector you are going to create. You may question me. My answer will be any type of vector they can be. They can be velocity, they can be forces. Basically, they assume the nature of the physical quantities of the vector given by your question. If my question deals with forces, then I cap is a force of 1 Newton along positive x-axis. If I am dealing with velocity whose unit is normally meter per second, then j cap will be a velocity of magnitude 1 meter per second, and that is along positive y-axis. Okay, so thereby anything multiplied with I cap, j cap, k cap, then, but you must not multiply two things simultaneously. That creates complication. Of course, that can be resolved, but not now, readily. So if with I cap, j cap, k cap, we multiply suitable magnitude, then they assume vector natures, they become full-fledged vectors, and it will be easy to deal with them, and our job will be comfortable, especially when you are dealing with the summation of vectors. But talking like this won't be making you clear altogether. Let us come down to the question. I am coming down to vector A. We know vector A has got its x component. Its x component will be ax, and ax equal to, or you may write here, vector A, okay, that is ax vector plus ay vector. We know ax and ay, they are nothing but x and y component of A. If you go to find the value of ax, we fall back upon our component method. Vector A is having a magnitude of 10 unit. That makes an angle 37 degree. So x component and x component touches the angle. So that will be 10 cos 37 degree. Okay, along positive x-axis, that's a vector. And other component will be 10 sine 37 degree. Okay, but you cannot you cannot add them all together. You cannot add them directly because these two are full-fledged vectors. One is along x-axis, other is y-axis. We know 10 cos 37 degree. Cos 37 is 4 by 5. When you multiply 10, that is 8, and that 8, it's a vector. If you write direction, that will be along positive x. If somebody writes in a descriptive way, plus 10 sine 37, sine 37 is 3 by 5. When you multiply with 10, that becomes 6. That will be along positive y direction, along plus y. But you know, writing in such a lengthy way and all that, this I cap and j cap and k cap will be helping us. Simply we write vectors x component as 8 I cap and vectors y component as 6j cap. I think you understand. Now we have found a way to algebraic way to present a vector in terms of I cap and j cap. Similarly, if I present vector b, of course, I must beg excuse because I got a bit less space available. We know vector b, its x component will be along negative x, that is minus I cap direction. And x component is how much? Bx is how much? That will be b cos 45. Cos 45 is 1 by root 2. So 6 root 2 into 1 by root 2, as you know, that will be equal to 6. So thereby, I can present b as minus b I cap. Minus sign is used because x component of b is in negative direction. And y component of b will be b sine 45. That is by. You may write it or may not, doesn't matter, but you know in your mind, by sine 45 is 1 by root 2, and that is along positive y direction, so that will be 6j cap. So now vector b, we write in the algebraic way. Okay. If we are clear up to this, then we come back to the resultant case. Resultant was a vector plus b vector. Now we put down their values in terms of I cap and j cap. So that is 8 I cap and that is 6 j cap. That is a vector plus b vector. Let me clear some space. B vector is, we know, that is minus 6 I cap plus 6 j cap. Once you write in this way, let me remove a line. Already this is discussed. So you know, now this looks like a algebraic expression. One thing, one precaution you have to take. So that's equal to or are equal to you add them. But when you add them, we know I cap, the vectors which are having suffix I cap, they are x vectors. The vectors which are having suffix j cap, they are y vectors. You should not mix them up. If you add them up, then you can collect all the I terms together, I cap terms together. This is 8 I cap, that is minus 6 I cap. So the result will be 2 I cap. But don't ever try to add I cap with j cap. They cannot be added. If they are added, then have to added vectorially. We are not going to do that now. And similarly, you do the same thing with j cap. Here we see 6 j cap, and here also we see 6 j cap. So total, that is 12 j cap. You may realize or not, already we have expressed the resultant. But somebody might wonder, kya hai bhai? What is this? What is this? Let me clear up some space. Clear up some space so that resultant we got as 2 I cap plus 12 j cap. But because you are beginning to learn this method, you may be a bit surprised. Maybe that is some I cap, j cap, but I do not get the magnitude, I do not get the direction. But the resultant is already in your hand. If you try to explain it, we know that this equation says resultant is a vector whose x component is 2. And because I cap is there is no minus I cap, that is along positive x direction. The y component is 12. And because j cap is there, that is along positive z. So if I take them into account, x component is 2. At the head of x, I put down the y component. That is not necessary, but that is for your clarity. Then resultant will be the sum of these two vectors will be a vector which starts from the tail of this vector and ends at the head of this vector. That is the resultant. Okay. And how much is the resultant? Finding the value, now you have to use trigonometry. That is 2 square plus 12 square. That means the I is coefficient whole square plus j is coefficient whole square. If there is some z vector, you also extend the idea, just like no extra idea or no novel idea is required. So that gives the value of the resultant. And if you are interested to find the angle that is making with positive x or positive y, you know tan theta will be equal to, that is y part by x part, that is 12 by c2, that is 6. And that implies theta equal to tan inverse of 6. Now you know we get the value of the resultant given by this and get the resultant direction given by this. I think it is clear. Okay, but one thing I must ask you, you must repeat the video again and go through, because in one go, you may not be clear on all the aspects. How to find the resultant using this unit vector method. Because our video will be excessively long, I am stopping here, but I must urge you to go to the video once more so that you can realize the true potential of this method. Okay, at the same time, think of the, the benefit and the negative side of it also, the pros and cons. Okay, thank you. If you like it, then give a like. You share amongst your friends, and please subscribe if you find it useful. Let us call it a day.